I'm working for IBM Storage Software Development. Today I'm going to explain how object storage can provide unified storage for IoT, and I will explain the three main topics on how to make that possible. The presentation was provided with the help of Sandeep Patil, Dasikant Eda, and Bill Owen. So in the next 10 minutes I will explain or talk about the IoT, the definition. What does it mean? What does it stand for? I will also talk about the storage requirements for an IoT platform. And I will also explain object storage enhancements to really support IoT workloads better. So coming to the first one, what does IoT stand for? According to IDC, it means the Internet of Things, IoT, is a network of networks of uniquely identifiable endpoints or things that communicate without human interaction using IP connectivity, whether locally or globally. And if you look at the graph below here, so you can see in 2014 we had 3.8 billion endpoints or devices being in use. Today, 2016, we have around about 6.4 billion. And if you look at the outlook, in 2020, it will be around 20 billion of devices. And then if you look at the checkmark of 2050, you see some icons for smaller devices, and that will show that this will even highly increase the number of devices that will connect to IoT. So, but what are the storage requirements, the primary storage requirements for an IoT platform? Gartner studied systems used for IoT and came up with those three points that are needed for a storage system to be used in the IoT space. First of all, we need scalability, a cost-effective, scalable platform that's able to decouple capacity and performance. That more or less means that with increasing capacity, we want to have stable performance. Second point is a self-healing architecture. The reliability is depending on the data factor. And we have several options here, like RAID 1, 2, 5, 10, or also erasure coding. But we would like to have a platform that automatically, dynamically configures that. The third point is data awareness, which is more or less giving context to the data and policy management, and also providing visualization tools for better business insights. So why should one use object storage for IoT? If we see in the past surveys, most of the survey authorities told that object will be the future in the IoT space. And why is that the case? Why are they telling that? Based on those 6 points listed here, object storage is designed to support large volumes. It comes natively with HTTP and REST support. It's designed as a linear scale-out architecture and as a distributed architecture. And there's also no single point of failure. And it supports heterogeneous data types. So based on those factors, people think that object will naturally fit for IoT. But the next slide shows that in today's world, based on Gartner's 2015 report, we can see that object is not used for IoT. We can see the real-time processing column here shown in red, that it's very important for IoT, the real-time processing. For real-time analytics used in IoT, memory-centric file systems and no SQL data stores are the appropriate storage platforms. And the chart shows that object storage works very well with active archiving and cold storage, but it's not listed under real-time processing. So what could help to make really object work for IoT workloads or in the IoT world? We think it's the following three factors. First one is to support in-place analytics, means running analytics directly in your object store. The second would be IoT data collection and adding privacy filters. And the third one would be native eventing, device notification and a better information lifecycle management in your cluster. So let's go to every single point in detail. The first one was in-place analytics. If you look on the left side, you see a traditional analytics in an object store. So that means you have your objects stored in your object store. If you want to run analytics, you have to migrate them to your analytics cluster. You run your analytics and you create your reports, which are migrated back into your object store to publish it. So obviously, you have to move data twice. That's not very performed and efficient. On the right side, you can see how Swift on file that comes with the Swift object store can help us here. With the help of Swift on file, we are able to unify the file and the object world. That means object data becomes available to us as a file. So we can run analytics directly in place where the data is stored. If you have questions about how that works in detail, we had a very long presentation in the Austin Summit, and I added the link to the video on the lower right side. If you have questions about that, you can also catch me after that presentation. So the second point was IoT data collection and privacy filters. And as it states here with the first point, data collection and maintaining privacy on IoT devices is a big deal, and that's true. We have to provide and ensure privacy. A proposal on how to achieve this would be to use a configurable middleware, as you can see on the right side, that filters custom data, means user privacy related data. The middleware can be told whatever comes from this device should be filtered in this way. It can also act based on metadata and can change the metadata as needed. Additionally, it can add expiration to the object and also can automatically decide on the placement of the object. Such functionality helps to maintain the privacy with the collected data. The next slide shows topic 3, which is about cross-device notification and information lifecycle management. For cross-device notification, an engine could be used, which acts based on rules and policies. Let's think about a washing machine, which you can see on the upper left side, that sends the remaining washing time or the powder fill status via an object X. It sends it to the cross-device notification engine, and the engine can detect based on the metadata from which device, means which washing machine, the message was sent, and it can detect based on rules if it should do something with that message, if it should forward it to a different device. It will also know to which device it would need to send an additional object or a newly created object, which is shown here as object Y, which could be sent, for example, to your watch. This cross-device notification engine exists as of today in the IBM Spectrum Scale software in form of the ILM policy engine. This ILM policy engine supports tiering of the data to different classes of storage and also is based on policies and rules. With the left side of this slide, I would like to summarize on how we think that object storage could be enhanced to fulfill the IoT platform storage requirements. By using the Swift on file, we are able to run in-place analytics without any data movement. With the Swift middleware, we are able to ensure data privacy as we can act based on filters. And with the built-in ILM policy engine, we are able to provide cross-device notification and are able to also tier the data as we need it. This configuration will help to provide a unified storage architecture for IoT. It will provide a platform for the billions of devices and endpoints that will send data and that needs to be analyzed and processed any further. So thanks a lot, everybody, for coming. If you have any questions, you can catch me outside.